Hey everyone, so I've been working on a new version of the Little Book of Algorithms, aptly named 2.0. And essentially, I just wanted to add in a lot more examples of programs and challenges as well, because I felt that there weren't enough challenges to really solidify the concept. So I'm going to essentially talk you through some of the first few right now. Page numbering might be slightly out, but apart from that, I think it's all good. So let's have a look at this then. We're going to look at the lowest number program to start with first of all. I might as well not show you in the document. I might as well just show you in the code, and then we can look at the different versions. So this is a program which essentially will output the lowest number between when two numbers are input. You can see that this is one number, it's an integer. This is another one. And we're saying that if one number is less than the other, then that number, if num1 is less than or equal to num2, then lowest becomes num1. Otherwise, the lowest must be num2. And then it says the lowest number is, we're concatenating with this plus sign. And because we're concatenating with plus, and there's two different data types here, this being a string and lowest being an integer, we have to cast it using string. And really the purpose of this tutorial is to look at how we can go from basic programs like this into procedures and functions. So let's just run the code first, and then we'll look at procedures and functions, and then we'll get onto the challenges in a moment. F5 to run. Enter the first number, 23. Enter the second number, 31. And hopefully it should say that the smallest number is 23. The lowest number is 23, which it does. The issue is that this program only runs once, and we can't call it again if we want to reuse that later on. And that's the advantage of having it in a procedure. So let's have a look at that in a procedure now. So this is the procedure. I'll just comment this out. What you've got here then, let's just ignore the definition for now. The first thing that we need to be aware of is that the program itself actually starts here, and I'll explain why in a moment. So once again, we've asked for the first number, same way as we did before. We asked for an integer input. We asked for the second number. And then what happens is we call the lower num subprogram. In this case, the subprogram is a procedure. And we're passing in first num is passed in, and second num is passed as arguments. So this first num here goes into num1. Second num here goes into num2, so they're passed in as arguments. And these two here are what we call parameters. They're local variables, and what that means is that when this procedure ends, num1 and num2 will no longer exist. First num and second num will still exist, so you could still output them, and we'll show you that in a moment. But these numbers won't exist, so the memory is released, and that's a much more efficient way of programming. The program itself remains the same, and we're just printing here. And let's just have a look at how this plays out. So because we've defined our procedure here, when we call it, it knows that it means run this here. So we have to declare or define our procedures before we can use them. So these are the first things you see on screen, but actually the computer's already read this in, you just don't really see it. Okay, so let's run the program. I know the indents look a bit out, but we'll see if it works. It looks fairly similar, 23, 31. And then just to demonstrate what we mean by that, those parameters or those variables being released, I think if I say print num1 now, that won't necessarily work because that's disappeared. Yep, num1's no longer defined, but we should be able to print first num, and that should work because that should still be in memory. Yeah, so that still works. Okay, the advantage of having this procedure then is that if you ever want to rerun this, you could call it again in the program, or you could literally just use it now as a function. Automatically it comes up with num1, num2 is telling you, is prompting you what comes next. So I can enter a couple of numbers, 23, 31, close bracket, and it works because we've already defined that procedure, and so we can use it anywhere, which is pretty cool. Okay, next version then, I'll just close it for the meantime, is what would happen if, let's see, I should have commented. Oh. So using like triple inverted comma there to just essentially comment these out. It's like a quick way of commenting out blocks of code, triple comma open and triple comma close up there. So the final subprogram that we're going to look at is going to be the function, and a function is advantageous in that not only is it useful to call a subprogram anywhere you want within a program or to be imported in other programs, but also you can actually use the values later on. And what I mean by that is, although this program seems quite similar, we ask for a first number, we ask for a second number. Let's ignore this for now. We're calling lower num and we're passing in first number and second num like we did previously. But what's happening now is that the result is returned. So if num1 is less than num2, that value num1 is returned. Where does it return to? It returns into lowest. So it goes from here into here. It's passed back. And that means we can output it here. The beauty of that is that you can reuse that if you had several numbers that you were passing in. Let's say this function allowed you to pass in 5 or 6 numbers, and you had a lower num function and you had a higher num function, then you could easily find the range because you've actually got that number back. You haven't just printed it, it's also stored in the variable lowest. Whereas in the previous example, it's not stored because we tried printing it and it just wasn't recognized. Yeah. So let's have a look at this now. The result won't look any different because it's just different ways of programming the same thing. But really for GCSE and as once you get through past the basics, you should really be comfortable with using functions. So we're going to enter the first number, 23, second number, 31, and it should still work. The lowest number is 23. If we want to call it, so we could do, well, if we call it now, nothing actually happens because we're not saying where to store something. So if I do that, actually it does work. That's interesting. So even though I've called it here and I've not printed, it's still printed there. Because lowest is still in memory from previously, I think. If we close this, it's a bit difficult to test, isn't it? But I did lowest equals 0, and then now if I do lower num 23, 31, what do we think? Do we think it's going to come out with 0, 23, or is there going to be some kind of error, or nothing happens? Oh, it does work. Interesting. But essentially it's showing that we can recall a function anywhere, and that value is now available to use because we've stored it in lowest. He says, but actually it's not, because the value's been returned here, but what's being output is lowest. So we've kind of overwritten it there. That's somewhat confusing, isn't it? The best way to do this would be to overwrite it by doing lowest equals lower num 23, 31. And this time it's going to get returned into here. And is it going to get printed? It will, I think it's going to be output anyway because we're returning it and we're running it in interpreter. It's not. When we print it, it should come out 23. Yeah, so essentially it's showing that you can run the function anywhere and it will always overwrite. So let's just try a different number, lower num. 18 and 5. And we can put a print around this. So we're saying print, whatever is returned into here and stored in there, I want it to print, so we don't really need to store it. We can just do that, and it'll still work. Yeah, so that's the beauty of using a function, is you can pass parameters in, like a subroutine, like another procedure, but also you can reuse it over and over again. And we couldn't do that when we're looking at basic programs here. So let's have a look at these were the other examples. Highest number. So here it's saying that write a subprogram that has 3 parameters, num1, num2, num3. I'd advise to handwrite these to start with, and then you can then run the code just to check that it works. It's good practice because in your exam, in your GCSE paper 2, you'll have to handwrite everything anyway. So you won't have a computer to run it. But then again, it's good to also test your code so that you can check whether it works or not. First thing I'm going to do is just get this into Helvetica so that it's more readable when we're doing this. Okay, cool. Did I set that to size 12? And I would say that you should have a go at this yourself. This is more like the answers if you weren't sure. Okay, so you've got these 3 parameters, num1, num2, num3. The program should take 3 numbers as arguments and return the highest number. So this is saying if num1 is greater than or equal to num2, and num1 is greater than or equal to num3, then clearly it's the highest, right? So then we're going to return num1. Yeah, and then we can do an elif. Because like the alternative is, well, what happens if num2 is bigger? So num2 is larger than or equal to num1, and num2 is also greater than or equal to num3. Then clearly num3 is the biggest set. I'm just using space because this isn't really an IDE, it's just me coding this in publisher, num2. And then do we need to write the last one? Well, we can just write as an else, can't we? We can just say else will return num3. Yeah? And actually moving through onto the next thing then is actually calling this. So the challenge after that is to call it, because if we had this in a new window, the indents are slightly out, so let's just sort that out. We'll do control left square bracket, type that up. I think that's correct. Yeah, let's call this highest num. Listen to this book of algorithms. We'll highest. Oh. It's a good name. And then let's run it. Oh, this needs indented. Yes, because after every colon we need to indent. But I was indenting with space on publisher, which is not a good idea. Okay, so you'll see that nothing actually happens because we haven't called our function. And in your exam, you might be asked to write functions and you might be asked to use them. So the next part is actually using it, and that is the next challenge. So here it says calling highest number. So we actually have the highest number program just written, but we're not going to know whether it works or not unless we call it. So let's write a code to call it. So we've got num1 in, and let's change all this back to Helvetica. In the book, got this spoke, not spoke on, but handwritten font. But actually, on the screen, it looks terrible. So num3 in, right, and we're going to ask for an integer input. And we say enter the second number. And that's because you've opened 2 brackets, so closing 2 brackets there. Highest equals highest number, and then we're calling that with these values here. So we're calling the function that we just made with these values here. So we'll do num1 in, num2 in, and num3 in. Okay, and then whatever value is returned, so when we're running this, it'll return num1, num2, and num3, highest value. It gets returned to highest, and then you can say print the highest number was highest. Here, I suppose you could do the plus and str highest, or you could just do com highest. Either one is fine. I don't really mind. And then I guess we could try this. We'll put this underneath our code and hope that formatting is okay. The only thing that's not okay is the speech marks. So publisher has, I think, a different encoding, so it doesn't read the speech marks as the same. I think everything else will work. Okay. Let's try this now. So we wrote our function. We have no idea whether it works or not because we haven't called it. So this is like the second challenge, is how to call it. Okay, let's see if it works. Enter first number 22, second number 25, 24, third number 1. And it says the highest number is 24, so it does actually work. Slight formatting issue is that there's, we should probably have a space here as well. Yeah, so that kind of shows you that this is the writing of the function, and this is the calling of it. And in your exam, these are likely to be two different questions, which is why I've set them out as two different challenges in the list book for algorithms. Moving on, then, there's another one which is another challenge for you, which is to do with options. So complete the subprogram below. It has a parameter called num, which takes a number as an argument and returns a subject. These numbers correspond to the following subjects. So 1 is computer science, 2 is music, 3 is science, 4 is PE. If the student passes any other value into num, it should return error. So we already know that. We already know that the parameter it says here is called num, so let's just put that in there. If num1 equals 1, return computer science. Num1 equals 2, return music. And then effectively you're going to do elif num equals 3, return dance, and then else. Let's just code it. Let's do that. So elif num equals 3. That's not else, because they could also put error, couldn't they? Return dance. Elif num equals 4, will return P. And then the else, because if they don't enter 1, 2, 3, 4, you effectively want to say that we're returning an error message, so return error. Yeah? And that would be that subroutine. So if they put 1 computer science, 2 music, 3 dance, 4 P, and then the else is an error message. And I believe the next challenge might be calling it, right? Yeah, so write a program which calls the subprogram options from challenge 2. I'm going to show it to up so that you can see that how it's side by side. That might help, right? So a user should be prompted to enter a number to choose a GCSE option. So let's call this option num. That's the opt num actually. Opt num equals integer input, and we're saying enter a number to choose a subject. And I'll show you this cool thing here, which is that if you want to have several things on a line, you can actually do a print, and you can do the triple quote again that I showed you when you comment, because that essentially means a multi-line, a multi line piece of code that this continues. So if we put that here, kind of get the idea. And close triple quote. What that should do is it should actually just output this all in one line. Let's just try that in itself, so you can see what that looks like. Print says, yeah. So internet choose subject. Let's just run it. Ooh. Oh, yeah, this is the slight issue of publish it when it's typing. You can't just copy and paste it. Yeah, can you see how this outputs nicely? And that means you never have to bother with like \n\n\n. You can just use this kind of like triple quote here. And then it asks you enter non-student subject. So if we say like 3, nothing happens because actually we haven't called our function. But if we call our function then, what you would be doing is you would be saying, okay, let's store, we'll store it in subject, and we're going to call options over here, and we're going to pass in opt none. And then effectively, you could then print out a subject in this computer science music tab P, but also you've got this error message. So you're going to have to actually put in if search equals error, then you can say, actually no, how many specific, number not recognized. And else you can say print you chose formula search, and that should work. Let's drop it all in and see what it looks like in idle. To me, you're probably thinking, well, why didn't you just code it like straight to idle? I suppose I could have done that, but you guys are meant to be handwriting it anyway, and we have no idea whether it's going to run or not in your exam, so it's kind of good practice. This is not good practice. Like copy and pasting it, you would be handwriting it. So I suppose it's tough. Why doesn't he just do final place here? Right. We also need our function, which we declared here. So let's get this all defined in here. So remember the definition comes at the top. Def options num. And we can actually do, I think, if I replace that. Right, which find options we've output this. We've asked it for a number, and if the subject is equal to error, then it says number not recognized. Otherwise, it's going to pick the subject. And I'll show you how you might loop this over and over. Okay. So in here, enter number to choose subject. We might say 2. Hope it says we chose music. Otherwise, let's say, for example, we pick a random number, like 3. Let's say number not recognized. So that's cool. But what would be even cooler is if when the number was not recognized, it went back to here. So how do we do that? Well, we could make this itself a procedure, and we could make it call itself. So we might as well call this main, indent this, and that means that any time that someone puts a number that's not recognized, we can actually return it back to main, well, return main, which means kill the current instance of main and rerun this. And not recognized. Try a number between 1, 2, 4. We'll call main once here to run it. That should go, I think. He says. Yeah, okay, and it's going to shoot such a second. You see, number not recognized, try number between 1 to 4, and it's basically called a new, it's called function again, a new instance of the function. It's called, it's killed the previous function and called a new main. So it lets you actually call it again, and a 1 when it says you chose complete science. Because we chose it correctly, it just ends in there. If you wanted to loop again, you could also do return main here and choose another option as well. Okay, I think, is that all I'm going to discuss? Yeah, I mean, there's some other tracing exercises, but I think these are quite basic, so I really need to go through this. I don't think I'm going to go through these. I just wanted to really go through like writing functions and calling them. Challenges 5, 6, I'm going to get you to do as well. But those solutions I'm going to post up. They're a lot more straightforward, and you can just actually run the code to figure out how it works, and then making this work, and I'll let you test that out yourself. But essentially, this is just practicing if statements and what happens when a number goes through. But you could code this and see what happens. You don't really need to know that. So hopefully that's useful. It's really a recap on functions and how you should use functions to make your code more efficient. Some of you might think, well, that's just really long. Why did we bother writing all of this code when we could have just written this and this slide here? Well, it's so that you can call it over and over again. So you can reuse the code, and you can get the code to loop as well. And essentially, you don't actually want your program to just run once and terminate. And also, you might have several functions in a large program, and they might be called several times. You might have a login function, you might have a register function, you might have a game function, a main loop, you might have a save score, you might have a load next level function. And so the notion of functional programming as a paradigm, I think what we call it, is really important. Hopefully that's useful.